Alright, so everybody, if you're watching this video, pause it, fill in the blanks. When I scroll, pause it, fill in the blanks. Everybody, at this point, we have to have these pretty well fast, all right? Because again, AP especially is set up to eat your time in places. We don't have time to be stumbling on derivatives. Everybody, we're really good at sinus, cosine. And remember, if you don't put the argument, I mark it wrong. If you just write cost, it's not right, right? Down here, the other one that you remember is derivative of cosine is negative sine. Did you guys catch that I put cosecant, cotangent, and cosine all on the same line? That's because they're all negative, right? So our one little trick that we can use is that we know any trig function that starts with the letter C is a negative derivative. Up here, guys, derivative of tangent is secant squared. X, derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent x. Derivative of cotangent is negative cosecant squared x. That's an S. All right. Product rule. I don't care what order. I'm always going to do it the same order as the quotient rule, just with the plus sign. So I always write it this way: f prime g plus g prime f, because then I remember the quotient rule as f prime g minus g prime f all over g squared. All right. I am absolutely positively trying to screw you up with pi cubed. Do not write 3 pi squared. It is a constant. Derivative of a constant is always 0. We're going to spend more time with limits to infinity. There's a whole section of it coming in the textbook, but I want you to recognize 1 over x squared. We can picture this as x gets big. This has to go to 0, right? This has to go to 0. Guys, when in doubt, remember, bigger power on the bottom than the top of a rational goes to 0. It's when the powers are equal that we can use the coefficients. Let's scroll. And again, if you're watching at home for prosperity, go ahead and try them. I'm going to keep rolling. All right. I actually put a little number in here, so we'd have to do a chain mixed in. Ooh. Everyone, let's do this one though. Derivative of any exponential is the exponential itself and then ln of the base. We know the derivative of e to the x is e to the x because ln e is 1, but we just know e to the x. So this is chain rule. E to the stuff is e to the stuff times derivative of stuff. So 3 times e to the 3x, or e to the 3x times 3. Derivative of ln x, 1 over x. Derivative of log bx, I always got to think about this, all right? It's 1 over, right, x ln b. I typically, and you'll see this when we start using these more often, I typically will rewrite this as an exponential, but it's there. Everybody, for continuous function, the limit as x approaches a of f of x, what's it got to equal? F of a, right? The limit has to equal the value of the function for a function to be continuous, because otherwise you have a removable possibility. Last two. Chain rule. F of stuff, so it's f prime of g of x times g prime. Then last two should be the 2 trig rules, I hope. All right, last two. Limit as theta goes to 0 of sine theta over theta. What is it, everybody? 1. And limit as theta goes to 0 of cosine theta minus 1 over theta. This is 0. Everybody, do not think it's 0 over 0 makes 0. This is just memorization, right? 0 over 0, you know, we did these proofs, right? Limits and squeezes. All right.